So today's video lecture is cloud deployment architecture. So the types of cloud or the various deployment models of cloud are categorized into four parts: public cloud, private cloud, hybrid or heterogeneous cloud, and community cloud. Public cloud is open to a wider public, and private cloud is implemented within a private premises of the institution and generally made accessible to the members of the institutions or a subset of them. So basically, in case of public cloud, the whole cloud infrastructure is outside somewhere else, whereas in private cloud, it is the cloud architect, the complete cloud setup is done in the on premise. Hybrid or heterogeneous, the cloud is a combination of the two previous solutions and most likely identifies a private cloud that has been augmented with resources or services hosted in public cloud. We'll talk about the community cloud is basically a cloud in which is specifically designed to address the needs of a specific industry or a specific community. So it can follow any other deployment model, public, private, or hybrid, but it is basically designed for some specific community sharing some specific interest. We'll talk about them individually one by one. So let us talk about public cloud. As it's been written in the earlier slide, that it is open to all. So the services are made available to anyone from anywhere at any time through the internet. And historically, public clouds were the first class of cloud that were implemented and offered. They offer solutions for minimizing IT infrastructure cost and serve as a viable option for handling peak loads on the local infrastructure. This is the key, point. This last line, they are capable to handle the peak load, and they serve as a very viable solution in that case. So, and the overall IT infrastructure cost is minimized, because here we are not supposed to purchase the hardware or purchase the software, wire, network switches, or anything. We are basically taking them, subscribing to them online, and there is all the infrastructure is maintained by some other person, or some other organization, and who's taking care of that maintenance. Everything is being done by them, purchasing. So lots of time and cost is saved, and they have become an interesting option for small enterprises. So basically, small enterprises or the startup companies, they don't have much amount of they don't have that much of money, or they don't have that much of it. They can't do that much of investment for purchasing highly expensive servers and the hardware. So it's a good solution for them to take that infrastructure online through the cloud service provider and then do their work. So by renting the infrastructure or subscribing to application services, customers are able to dynamically upsize or downsize. It's also another good solution that we can dynamically scale up or upsize or downsize the IT infrastructure according to the demand. So this is called scalability, dynamically scaling up and scaling down the resources. Currently, public clouds are used both to completely replace the IT infrastructure of enterprise and to extend it when it is required. Public cloud is a fundamental characteristic of public cloud is multi-tenancy. So what do you mean by multi-tenancy? It means when more than one the same resources, if they are being shared among many people, many tenants. So those sharing among many tenants is basically, this is called as multi-tenancy. So public cloud is basically meant to serve a multitude of users. Many users can share it, not a single customer. And this is a good feature of cloud. Any customer requires a virtual cloud computing that is separated and most likely isolated from other users. So whenever you require some resource, you are request for some resource, let us say you are taking some virtual machine, you are creating a virtual machine, that resource will be separately allocated to you, and that virtual resource won't interfere with other virtual machine that is given to you, and this is completely isolated from the other services as well. QoS management is a very important aspect of public cloud. So quality of service management, how to deliver a good quality over the internet, how to provide this load balancing and all these things. All these things are basically done. The quality is handled by the service provider, and of course we sign an agreement in the SLA at a time at which quality we are looking for, and different they for having a very good quality, advanced quality, we may need to pay more. Hence, a significant portion of the cloud software infrastructure is devoted to monitoring the cloud resources. So because cloud service provider is responsible for providing good quality, so the provider has to use certain set of softwares, software management softwares, infrastructure for monitoring the entire cloud resources. So this is not just I mean, the softwares are not just for providing services. There are many software which are only solely responsible for doing that management task, and to like billing software, performance monitoring software, where log generation software, network monitoring software. They use many software layers for managing all that cloud infrastructure. So and the contract is being made, yes, of course, that contract regarding all these quality or other factors. This is done with the pricing, billing, everything done with the user. Public cloud can offer any kind of services like infrastructure, platform, applications. Okay, for example, like Amazon EC2, you have, I hope that you have gone through my video tutorials on Amazon EC2, how to launch the instance using our service, how to access it using PuTTY, how to host a web page or a website. So all these things are already being delivered through a separate video tutorials. Google Application Engine is, of course, is one of the good public cloud service, and this Amazon EC2 is ours, public ours, and this is public PaaS. Private cloud are appealing. Now next is your private cloud. This is appealing and provide a viable solution to cut IT cost and reduce the capital expenses, but they are not applicable to our scenarios. So of course, because it is cloud, it is obviously is provides designed to reduce the overall cost and capital expenses, and but this is not applicable in all kind of scenarios. Like public cloud, in if we talk about public cloud, the provider has a complete control on the infrastructure, and the customer, even the customer's core logic and sensitive data are also under control of public cloud, because our data is not our under control. We have lost the physical control on our data. Data is somewhere else at the remote server. So in case of public cloud, we are trusting on the provider that they are keeping our data safe and not disclosing it. But in some scenarios, like institutions such as government and military agencies, their data may be very much sensitive, that we can't take that risk of giving that to some other person or some other organization. So in that case, public cloud may not be a suitable option for giving the sensitive data to them. So it's a because the risk of security breaching can happen in such a case, and this could expose such information to others. So the information can be disclosed or can be shared, and but this information is very sensitive to me. It's my private information. I don't want such things to happen, so I won't go to public cloud if we are talking about government bodies or some banking, military agencies. So in that case, private clouds are more suitable, because in case of private cloud, the complete cloud infrastructure is created using the cloud management softwares in the own premise. So the complete physical infrastructure system, the physical hardware, everything is utilized at the at the organization's premise. Whosoever wants to create a private cloud, let us say Graphicera wants to create a cloud, so Graphicera will be responsible for providing all those things, server and all, and then the service providers team will come and then set up the complete private cloud there. All that setup will be done by them, and whenever if something went wrong, or some error occurs, something, then online troubleshooting, offline troubleshooting, both are provided. But the main thing is that in private cloud, the complete cloud is set up in the premise. So what is the good point in that? The security is less concerns are less critical, because our data is under in our own premise. Now one more thing is, like, instead of pay as you go model, which is followed usually in most of the clouds like public cloud, but there could be another schemes in this case, and it may depend that how to provide that, how to do that billing and all. It may be done departmental wise or section wise, or may not be done, may be handled completely by the provider or owner. So this all depends how the billing is done. Strictly it may not follow that pay as you go model. And yes, of course, security concerns are very less critical. Moreover, existing IT sources can be better utilized, because a private cloud can provide services to a different range of users. Uh, Now, this is also important aspect, that like if some third party organization is coming to set up the private cloud, like EMC Square, Amazon, or some any service provider is coming, so it may happen that a third party compliance standards or the rules, protocols, procedures need to be followed by the organization while deploying such kind of setup. So compliances means rules and regulations or procedures that to be followed by the organization. They are using their, if they are using their software, commercialized softwares in the premise. This could not possible in the case of virtual public infrastructure. This is a complete software stack. You can see here that this is a completely physical infrastructure where we'll be having an extra upgrades, clusters, data centers and all. And then above that, because this is a system infrastructure, and this is the management layer which I have talked earlier. And here we have seen that we have talked about in the earlier lecture that this part is basically the software layer part, software management part, which all those software which are used for managing the hardware or the system infrastructure, all those software that are called as ARS management layer, they're part of the ARS management layer, they are called as core middleware. So like KVM, Zen, VMware, all these are the softwares which will be used for creating the virtualized resources, and all those virtual resources, everything will be used by these softwares for creating a framework of cloud orchestration, creating cloud, setting up the cloud, creating controller node, control network node, compute node, and storage node, communicate how the communication will happen between these nodes, and all the configurations, automating that configurations and all these things. There are lots of things I can't even talk about here, but this is the basically these are the basically softwares which are used for creating the cloud, for setting up the cloud. They are cloud management software. So basically all these using those cloud management software, using such or some other softwares which basically this is a one part of these softwares. This is a hypervisor, and they use as the hypervisors as well, but they are very large softwares, they're very small softwares, and all these softwares are mainly intended for managing the infrastructure or the system infrastructure, how to orchestrate the entire infrastructure, so, and automate most of the things. And then after setting up all these things, then actually the resources or system infrastructure, the services may be available for future. But and along other than this, so some of the providers also provide the user level middleware for the past developers. So many of the tools like Aneka, Zemari Pools, Restra Cloud Server, database basically, RDMS or RDS, and some other DynamoDB. Some other many softwares are there which will be used by the software developers, and they are suppose these softwares for developing softwares are also supported by some of the cloud service providers. So this is also part of software stack. So this is for application development tools, and this is for system infrastructure management related tools, and these are the system infrastructure. This is a complete software stack which is utilized by the it's written like a private cloud, but most of the clouds uses the same architecture, same software stack. Now cloud there are certain points which are written. Please go through them one by one. Customer information protection, it's understood that because we are having the data in our own premise, so customer information is protected. Infrastructure ensuring SLA, service level agreement, quality services are obtained, and they provide a very good quality of service, such as appropriate clustering, failover, data application, system monitoring, maintenance, disaster recovery. So all these are the functions which ensures that good quality need to be maintained, and all these factors are written in an SLA. And all the public cloud vendor provide some of these features, but not all of them are available as needed. So all these are the features that are provided by private, and most of them are provided by public cloud as well. So now next talk about latest hybrid cloud. Hybrid cloud means hybrid means more than two clouds can be created. A cloud infrastructure or cloud setup can be done in which offers both public and private cloud services and public cloud services. So this entire setup could be utilized for offering both kind of services. This is hybrid cloud basically. So I'll talk about the you please go through them one by one. We have already discussed this, so let's talk about this. The major drawback of private deployment is the inability to scale on demand and to efficiently address peak loads. So this is the drawback of private cloud, and you can quickly relate it, because if we talk about private cloud, it might happen that I have created private cloud using 10 servers only because I don't have that capacity. But if the demand increases, number of users will increase, and it will be difficult for me to scale up my servers because I have already done a setup using 10 servers only. So it will take time to purchase more servers, high-end server, then connect them to the existing infrastructure, do the configuration and all. So all these things are automated through the public in the public cloud, because public cloud is a giant IT company, so they are having a very infinite resources. So yeah, this is private cloud is incapable in that, in doing the scalability, and all factors are not, and they are not efficient to address the peak load because of the same factor. uh, but in hybrid cloud, because it offers both public and private, so it's easy to grow and shrink the provisioning and releasing resources on demand, and this is called cloud bursting. The security concerns are then only limited to public cloud because it is hybrid cloud, so the concerns which are with private will remain there, concerns which are with public will remain there. So this is hybrid, so both the characteristics are will be here in the hybrid cloud. It is a heterogeneous cloud. Fine. So like interpret is one of the example. Community cloud is again very simple. Community cloud, basically a cloud which can be, public cloud, private cloud, or hybrid cloud, or any it can take it can be any of the cloud, but it can take any of the, architecture of public cloud, hybrid cloud, or private cloud. But the community, it is called community cloud if in case if that infrastructure is shared, it is shared and managed by a third party, or where this is basically specific communities interested in accessing and sharing that infrastructure. So basically, if we talk, if let us read these lines one by one, which is given by an IST, that the infrastructure is shared by several organizations and supports a specific community. So several organizations which are having some common concern. So several organizations may have different communities. For example, Graphicra University is having a cybersecurity research group, and let us say University of Newcastle is having a cybersecurity research group, and both the research groups are collaborating. So we are having some specific communities and specific organizations, and these communities are sharing some infrastructure for doing that research work and all. So if they are having shared concern, because mission will be same, because we are working on cybersecurity, security requirement will be same, policies and complaints and considerations will be same. Like if we are working with cybersecurity, then Cybersecurity Act will be applied. If you are working with health related projects, the Health Security Act like HIPAA, all these things will be applied. So all this, we are having similar missions, similar security requirements, policy complex considerations are similar. So in that case, because specific communities are sharing the cloud, that case, that is called as community cloud, and it may be managed by the organizations or a third party. So different organizations can manage it, like Graphicera and the University of Newcastle can, both of them can manage it. That can be created at some one's premise, and but that will be shared with other premise. And it may happen that Graphicera and the Newcastle, which is in Caledon, Australia, maybe that they are sharing that infrastructure which is created in the public cloud, like let us say AWS. So in that case, that AWS has created certain sources infrastructure that the AWS sharing between only two specific organizations, that is specific infrastructure between GU and Newcastle. So this is one of the example in which we say that the resources or the infrastructure is shared among the community, specific communities sharing common interest. I guess I'm all. Most of the companies follow the same model. Most of the such organizations follow the same model. Fine. So this is what, and the candidate sector for community clouds are follows, like media industry use it, healthcare industries uses it, public sectors, government processes uses it, scientific research uses it. So this was all about the what is the deployment model of cloud, and the details about what are the various factors which how they are differentiated among each other. So I hope that you understood all these things. Thank you.